ago, months ago, I don't know, it's been a while, we did part one of Not Your Grandmother's Data Warehouse Fast Track, and it was a rather long presentation. We never really got into the loading strategy, so this is a continuation of it, part two. It's going to be mostly theoretical. I did have demos ready. Unfortunately, after a year and a half of training and 2 different laptops, I've lost all the data files, so I can't complete the demos. So bear with me with this, and we'll try to slug through the theoretical portion to make it as clear as possible. All right, so there are 2 main tracks when we do fast track loading. We have our historical or one-time loads. You may also hear this mentioned as data migrations. So we've got our brand new fast track data warehouse. We've got empty tables. How do we get those loaded? And once they're loaded, how do we maintain them and get them incrementally loaded and still maintain our fast track methodology? The main goal of this is to keep our data contiguous, regardless of the load type, historical or one-time or incremental. The goal is to keep the data fragmented. And this example here shows how data can become fragmented. These are logical fragmentation, where I have data pages interleaved between my extents. So in my first extent, I've got data from page 1, or table Y, table X. Extent 2, I've got data from table Y. Well, because Fast Track's trying to read 512K reads and read aheads into 2 meg blocks, basically what happens is I'm reading in fragments from table Y and discarding them. So I'm kind of blowing away, I'm losing my Fast Track scan-centric workload. So these methodologies here are to try to keep these pages contiguous for each of the tables. So for historical loads, there are 2 main topics. There's the bulk insert with a heap and bulk inserts with clustered index. The first one is probably the most common and fastest. And here are some workloads that we'll look at for historical one-time loads. These are going to be loads that exceed available system memory. So we want to try to keep these as fast as possible, avoid hits on TempDB. And these are loads that can take advantage of high concurrency and high volume load operations, BCP, bulk insert. So the simplest method is to just go right into a heap table. We bulk insert to heap. We can reduce time by running parallel load operations. The key hint here is to use tab lock option for the bulk insert. One thing to watch out for is TempDB. When we run the bulk insert, set the tab batch size so we make sure that everything fits in memory rather than spills over into TempDB.
On the
yes, Larry.
properties, is it also addition to table lock? You have some database free options such as Workload or Sync?
Yes, the question from Larry is what would be the recovery model for this? And for most operations, this is going to be simple. We tested this out with bulk log, even with the flags. We were finding the checkpoint was still killing us. And Andy and I have perfect examples of this where it seemed to go really fast, but then after a while it starts slowing down. We'd start off about 1 million rows a minute and then start dropping down to about 600,000 and 500,000 and the tens of thousands. We set the database recovery model to simple, and all of a sudden we maintain the million rows per minute throughput throughout the entire load.
Okay. In addition to that database recovery model, when you indicate a heap, do you also infer from that that there's also no non-clustered index?
Correct. So Larry's question was, do we also infer that there are no non-clustered indexes? And the answer is yes. That is one of the principles behind Fast Track, index light. So when we want to go into a heap, no indexes, just blast the data right into the table. Remember, our goal is scan-centric workflows. We're probably going to scan the table anyway because we're doing summary type queries and aggregations. So we're going to read the bulk of the table anyway. So we're not really concerned about, date ranges.
And in regards to additional items that assist in this, any unique startup parameters for the SQL Server service, -E, -934, or
Yeah.
834 rather.
So the question from Larry is, what are our startup parameters? And those are covered in part 1, but to rehash those, -834, trace tag 1117, 1118, we want a -E for...
1118, really?
Yes, 1117, 1118,
They've been banned a long time ago.
620, and 834. Those ones off the top of my head. All those are involved around minimally logged inserts, even extents, and parallel growth, or even growth.
And how do you ascertain what is the appropriate batch size? So what is the methodology used to determine, first of all, that TempDB sorts do take place?
So you'd have to watch when you're doing your load. Are we spilling over to TempDB? And so we could look at sysdm task space usage and session space usage. See, is my query actually hitting TempDB? Does everybody get that? In fact, I just used session space usage at...
Hey, Doug, this is Raj here.
Hi, Raj.
I don't know if you're going to cover this, but any recommendation with respect to pre-initializing the files?
What do you mean by pre-initializing the files?
Pre-going in,
Yeah, so that's part of the fast track part 1, where you grow out the data files contiguous when you build the fast track data warehouse. So we build out the files to their maximum size at that point. So now when we do the loads, we've got those contiguous blocks laid out on disk.
Is there any example or rule of thumb?
Well, typically when you are creating a large file, like a terabyte plus, the recommendation is to create it with not initializing all the extents and so forth. So the question is, in this case, do we do that? Because as the data is inserted on the fly, it's going to start creating extensions, and that might slow down the load. So that's what my question was.
Okay, ask the question again, Raj.
So typically when you're creating a large data file, if it is very large size, to shorten the time to create the database or the file, you typically don't initialize all the extents, right? You just create it. So the file is out there.
Correct.
So my question is, in this fast track scenario, if you are creating that kind of a size database, would you rather take the hit when the database creation is done with how long it takes to get that database created and everything initialized and in place, versus you want to do that as the data is inserted?
Correct. Well, you want to take the hit for the database creation. At this point, what we want to maximize or minimize is the load time. So we want to have the database files already created, the extents laid out, so that the data is just going in from extent to extent. So let me back up a slide. So in this example, we show the mixed extents. The goal is we've got an empty database file here. We've got our tables created, so I want to start loading table X, and I want to use that bulk load, so then all these extents get allocated to table X at once. Does that answer your question, Raj? We want to take the hit for the file creation at database creation time, and then use the unallocated space then to load the tables. So this is the example of how the bulk...
Yes, it does. Thank you, Doug. I was on mute, sorry.
Okay. So this is an example of just how we would load from the source, do bulk insert into our destination tables as a heap. Probably not realistic for most loads. So another option is to bulk insert into a table with a clustered index. Again, we're going to use a bulk insert, and we're going to load directly into a clustered index target table. Again, we're going to try to get everything in memory, keep it from going into TempDB. So here we want to pre-sort data if possible. That would mean using our select statement or sorting it in the staging table and then loading it into the clustered index. It helps by having the source and target column attributes aligned, having a clustered index on the target and the source being the same. The staging table is empty, so I'm going to load it, an empty staging table with a select statement that orders the data, so that when I do my insert select, that the data is already ordered as it goes into the table. The key here is that we want to use max.1. If we go any higher than that, we have the possibility of the multiple threads interleaving the data. So what this basically looks like, we're going to use a multi-threaded insert to load the stage table. So that's where we're going to pick up our time, load the stage table as fast as possible using parallel processes, whether they're bulk inserts, BCPs, or if my data source is Oracle, a container that does selects. And then we will do the bulk insert from the stage table to the destination. Now, this is from the Fast Track Guide using partition switching. This is very complicated, it's very in-depth. I could read all this, but it's probably best just to show you an example of what it would look like via the diagrams. So I've got a base staging table, and it's basically just a heap. Then I've got a number of heap tables that map to my partition clustered index destination table. So I build out just an empty base staging table, it's a heap. I build out a number of heap tables from one to end that map to my partitions in my destination table. So then, again, to speed up the process, I'm going to do a bunch of parallel inserts into the base staging table. So I'm going to bulk load and parallel into my base staging table. And then again, I can parallelize this process and I can load each of the heap staging tables in parallel. So basically each one of these queries here is a ranged query. So I'm going to pull data out of the base staging table into heap 1 that matches the clustered index and the partition for my target table. Same with heap table 2. I'm going to have a query that maps the heap table 2 to partition table 2 and my destination. And then at the very end, I'm going to start partition switching. I'm going to start partition switching into my destination tables. So at that last part, I'm doing a metadata operation very fast, and it keeps the data in the destination table contiguous. I see a question coming from Larry. So the comment from Larry is that typically when we do this partition switch, it's going to require a table lock or schema lock, and will block the users. Remember, this particular solution here is for a one-time load. This is just a fast way to get the data loaded from our source to our destination and keep our fast track strategy of contiguous data blocks.
Hey Doug, what if the source data is not partitioned by the customer?
That's fine. We're just going to load the base staging table. It could be a heap. And what we're going to do is we're going to partition it with these mini staging tables out here, Raj. And then we're going to query, basically we're going to fill these heap staging tables with a query that aligns to the partition.
So having a partition data is not a requirement to get the data loaded?
Correct. So basically in this situation, we've got a heap table here. We've got unordered data coming from the client. We're just going to load the base staging table as fast as possible. And then we're going to build these mini heap staging tables that are partition aligned. And I say partition aligned, they're not necessarily partitioned. This heap staging table 1 contains a subset of data that maps to partition 1 of the destination. Now we move into the incremental loads. And again, we have similar methodologies. We have bulk insert into a heap. Now we have bulk insert into a clustered index destination. We have a load staging table to a clustered index. And then the third option is partition switch volatile tables. So the workload sizing for incremental loads are going to typically follow They're going to be small size relative to our memory, and the load sort operations will fit into memory. Now, these are best practices, and what we found out at Ernst & Young, and I'm thinking even at other engagements like SSM and regions, incremental loads typically do not follow this best practice. You've got a lot more updates than you have inserts. This methodology here assumes that you're only doing inserts, not updates. And also, we got a small size relative to the total rows in the destination table. So,
hey, Doug, you mentioned SSM. Is there any similarity in terms of tools or command line utilities that you could use on a fast track that are available on PDW, or are they completely two different ways to load data?
You could use the same methodology to load a PDW. And since that's what we're doing at SSM as far as the POC, we're using the full historical load methodologies because everything that they're doing are truncates and reloads. Their data is small enough that we can afford to do that at this time. All right, so as far as the incremental load for the heap, it's the same as we do with the full. The goal is to reduce time by parallelizing operations. Again, use tab lock and adjusting the batch size. Here's our load methodology again, and I note down here that this is typically used when you have truncate and reload type operations. If you have updates, type 2 changing dimensions, where you have updates, this is probably not going to work. So now we go to the incremental load of the staging table. We're going to start off by performing a serial or multi-threaded bulk insert into the empty clustered index staging table. Again, we're trying to avoid sorts that spill over to TIP-DB, so we want to adjust our batch size appropriately. And again, the goal is to get the data into the staging table as fast as possible. And at this point, fragmentation is not a concern because since this is empty, it's always going to be rebuilt later. So then we go from the staging table, we use insert select statements with max.1 to populate the clustered index destination table. Again, we use max.1 so we can avoid the multi-threaded process interleaving data. So here's what this process looks like. I've got my stage tables, I've got my destination tables. I'm going to do parallel inserts from my source to the stage table. Then we use a insert select statement to populate the destination table. Again, these are all inserts. This does not take into account updates and changed data. That is outside the topic of today's conversation. So this is a very special case, and I copied this out of the Fast Track 3 reference guide. We have a situation where my target table, and this would be, Larry, a Silverlink scenario, where I've got one particular range of data or partition that is undergoing very volatile transactions, a lot of changes. Everything else, once it's in there, is static. So what we do is we partition a clustered index, and then we partition switch into the active partition and leave everything else in the historical. So rather than go through all the details of this, and I will post not only this deck, but the Fast Track 3.0 reference guide on the portal, so you can read through this section. It's like 4 paragraphs long. See, this is part of it. We were going to create 2 file groups, build a clustered index on the partition table, and then we're going to build a view that unions the destination tables together. So here again, I've got my base staging table. I've got my heap tables that map, and I've got my partitioned clustered index destination tables. So I'm going to load my base staging table. I can do this in parallel. I'm going to load my heap staging tables, and now I'm only going to switch into the active partition of my destination. Because remember, everything else out here, once I got it loaded in, it's not changing anymore. it's basically static. So this is why I say Silverlink would be a good example. Everything within the last day or two is what's changing for them. So everything in my first partition is what's going to change.
I'm not clear on, you're doing multiple partition switches for one partition? How that what you're doing?
Yes. So it could be ranges of data. It could be just, it does not necessarily have to be multiple heap stages here. It could be just one, Larry. The goal is I'm only going to populate the most current partition of the destination table.
But you're not doing 3 different partition switches. You just build a view across all those staging?
Correct.
Okay.
There it is, right here at the very last. One more button click. Once data becomes static, roll in the historical file group and create a new file group for the volatile data. So then I have a view that ties all these together. So again, all of these methodologies for incremental data assume inserts only. They do not take into account updates. And that's pretty much what I have for today. Here's some references. 2008 Loading Performance Guide, Fast Track Loading Overview. And I've also got the, for those in the office, you can see the Fast Track Configuration Guide up here. So any questions regarding the fast track loading methodologies?